Hello once again. Today we are coming to continue with our tutorial. Today's topic is bond valuation. Last time we did stock valuation. Today we are focusing more on bond valuation. We have a way of financing an organization. If you happen to be a general manager, you can either go for loan or you can issue shares. If it's a company, you can issue shares. That is stock valuation. Now we are taking the assumption as if the company go for loan. Let's say you go for bond. When you go for bond, you have to value it. You issue a paper. The bond is a paper. Now, if you take, for example, the government treasury bill, it's a form of a bond. So the government give you that paper as a certificate indicating that you have lent to the government. So at the end of the year, the maturity time, you have to submit the paper for your money. Now, when you go for a loan, the borrower and the lender. Now, the lender gives money to the borrower. Then the borrower gives that paper certificate to the lender, indicating that the person has given money to him. Now, if you lend to a government or let's say an organization, an entity, that is you are the borrower, surplus earner. So you've given your surplus to them to run their organization, to run their activities. Now, in bond valuation, when we give the money to the person of, let's say, 1 year, 2 years, 3 years, 5 years, or sometimes perpetuity, now we have an interest payment that you, the lender, are going to receive. Sometimes it comes monthly or yearly, depending on the arrangement between the lender and the borrower. So in bond valuation, we have to understand some of the terminologies like coupon payment. The coupon payment is the monthly or the yearly interest payment that the lender will receive. And we have another term, par value or face value. When you say face value, it simply means that when I give when I lend to the government, at the end of the maturity time, at the end of the year, how much am I going to receive from the person? That is face value. That is face value. So you have to take all this into consideration when you want to value a bond. Now, I talk about coupon payment. Coupon payment, CP. I talk about face value or par value, FV. Then here we're talking about the bond price. The bond price. Let me say bond value, BV. Then we have the interest rate or yield to maturity. Some people call it YTM or R. That is interest rate. The yield to maturity is the interest rate. The bond BV here is the bond value or the price of the bond. Then the FV here is face value. Then CP here is what? The coupon payment. Sometimes they say you give money to someone and the person is going to pay you 10% annually for 5 years on that, on the face value. So that is the coupon rate is 10% annual or monthly when it's given to you like that. So now let's go about the formula for calculating the price of a bond. Price of a bond value is equal to the income the cash flows for the period. So if the first year you are going to receive coupon payment, that is C, plus another year you are going to receive another coupon payment, another C. If, let's take for example, you've lent to someone for 5 years, so plus another C, plus another C, plus another C, plus the face value that you are going to receive. But because it's going to be in the future, we have to discount everything to the present. So this is how much you are going to receive for the first year. So if you discount this, giving you the interest rate, and you know the discount factor is 1 plus R. But because this is the first year, it's raised the power 1. Then this is 1 plus R raised the power 2. 1 plus R raised the power 3. 1 plus R raised the power 4. 1 plus R raised the power 5. And you know, with the face value, at the maturity time, you're going to receive that money. So we have to discount that one to the present. And it will happen at the 5th year. So that one to 1 plus R raised the power 5. What is 5 years, 4 years, 3 years, 6 years? It's very, very simple for you to go with this formula. But what is 20 years, 15 years? Then it becomes complicated. Then in mathematics, algebra, we have a way of what? Deducing the formula. Then so as the number of years increases, it's very, very complicated. So in that way, this is the formula you are going to use. And here, as the number of years increases, now this is the formula we use to calculate price of a bond. Now, C here represents the coupon payment, and you know, because you are going to receive it the same value, the same amount for monthly or yearly, we use the annuity. This is annuity, constant payment. So this is the annuity formula, constant payment. So the C here represents the coupon payment. If, for example, you lend to someone for 20 years, and every year the person is going to give you 10 cedis. 10 cedis. So this is how you go about it. This C represents the 10 cedis that you are going to receive every year. And because it's the same, then we use the annuity formula plus the face value. And you know, the face value is different from the coupon payment. So we cannot add to that. So plus face value, then we take the discount factor. It gives you how much the person will pay for the bond. So if someone says, okay, who will give me money that I'll pay you at the end of 20 years, 1,000 Ghana cedis. Every year I'm going to pay you 10% on that. So every year I'm going to give you 100 cedis. So the 100 cedis, that is the coupon payment, the cash flows that you are going to receive every year, constant payment, coupon payment. Then at the end of the 20 years, I'll give you 1,000 Ghana, giving you interest rate of, let's say, 15% or 12%. Then you use your formula to compute how much you will pay, how much you, the lender, will give to the borrower. So that at the end of the 20 years, the borrower will give you 1,000 Ghana. I hope it's very, very simple and you understand it. Now, let's take a formula. Let's take a question. I think the question will make it simpler for you. Now, a bond goes for the face value of a bond. Face value of a bond is 1,000 Ghana. Coupon payment is 100 cedis. So if I say coupon payment is 100 cedis, it tells you that the coupon rate is what? 10% of the face value. Then let's take the yield to maturity or interest rate, YTM, yield to maturity or interest rate, to be 12.5%. Let's take the number of years, the maturity. The bond matures at the 8th year, so N, the maturity is 8 years. Let's use our formula to compute how much the lender will give to the lender will give to the borrower, giving you all this information. The borrower will say that I will give you 1,000 Ghana at the end of 8 years, but every year I'm going to give you 100 cedis, giving you interest rate of what? 12.5%. So how much will you be willing to pay for such a bond? Now, the bond value is equal to 100 cedis into brackets 1 minus 1 divided by 1 plus R here. Now R is what? 12%. That is 0.125. Okay. 0. So plus 1 gives you 1.125. All divided by R, and R is what? 12%. 12.5%. So 0.125. This with the power 8 plus 1,000 Ghana cedis divided by 1 plus 0.125, which is 1.125 with the power 8. So you use your calculator, then you compute everything. It gives you how much you'll be willing to pay for such a bond. I hope it's clear. Now, sometimes you'll be asked, giving you this information, you'll be asked to compute the coupon payment or compute the yield to maturity. We have a way of doing that. I want to give you the formula for computing the yield to maturity. Then I will explain to you the relationship between yield to maturity and coupon payment, and it's going to help you in decision making. If it happens to be a general manager of a company, or if you want to invest in a certain company giving you information, then you will know whether to purchase that bond or not. Okay. We have a bond value. We have face value. We have yield to maturity. We have coupon payment. Just see. The number of years to maturity. Now, you want to find yield to maturity. F is not given to you. So the question can be the price of a bond is, let's say, 889.2. Let me put it over here. Let's say the bond value, the price of the bond is 889.2. The face value is 1,000 Ghana, 1,000 cedis. Now we don't know the yield to maturity. Now coupon payment is 100. That is, the coupon rate is 10% of the face value. So it gives you 100 cedis. Now, number of years, 8. How are you going to compute the yield to maturity or the interest rate? This is the formula to go about it. And when you use it, see, this is the same question that we use to compute. So when you do that, you will see that you get that same interest rate. Now, yield to maturity, YTM. or interest rate is equal to the coupon payment plus, into bracket, face value minus the bond value. This divided by the number of years, that is the maturity. Then you divide all this by face value plus the bond value. Just this divided by 2. I hope you can see. The yield to maturity is equal to the coupon payments that you are going to receive plus the difference between the face value and the bond value divided by the number of years or maturity. All this divided by face value plus bond value divided by 2. It gives you the yield to maturity. I hope it's clear. So when you take this, yield to maturity or the interest rate is equal to C is what? 100 plus, now face value is what? 1000 minus bond value is 809.2. This divided by 8. All this divided by 1000 plus 889.2. All this divided by 2. So when you compute this, it gives you the yield to maturity or the interest rate. It's very, very simple. Now, sometimes you purchase a bond and they are going to pay you monthly or yearly forever. That is perpetuity. So the price of that, the price of such bond, perpetuity, so with that one, no face value, forever. So with perpetuity, the bond value is equal to the monthly payment or the yearly payment, C, that's the coupon payment, divided by the interest rate or the yield to maturity. It gives you the price of the bond. I hope it's clear. Now I want to give you a relationship between interest rate and bond value or the price of the bond. When we're computing the formula, you see that the bond value is equal to C into brackets 1 minus 1 divided by 1 plus R raised to the power n, all divided by R, plus the face value divided by this non-factor of this. Now you can see that there is a negative relationship or inverse relationship between yield to maturity or interest rate and that of the bond price. So it tells you that when interest rate increases, the bond value will go down, the price of the bond will go down. And when interest rate decreases, bond price will go up. When you purchase a short-term bond and long-term bond, we use a theory that the expectation theory, segmented theory, and the liquidity preference theory will tells you how you get the rate for short-term and the long-term bond. So, for example, you purchase the government treasury bill. We have a short first quarter, let's say the first 4 months, the middle of the month, let's say first 6 months, and we have 1 year. For example, when you buy 3 months bond, they give you the interest rate. When the long-term bond has a price risk as compared to the short-term bond, because with that, at the end of the 3 months, you can roll over to the next 6 months and another year. But with the long-term one, you have to wait till maturity, the end of the year. So if interest rate increases, that one, the long-term bond will not get it, because you have to wait till the end of the maturity date before you can roll over. I hope it's clear. That is a little relationship between short-term and long-term. Basically, that is all for bond valuation. Thank you very much. Next time, we are going to talk about the theory of rational expectation in the market and the efficient market.